Welcome to the Robo Connect 4 Automatic Connect 4 game.
A conventional Connect 4 game board requires two users to each drop their color of token in order to connect 4 in either a vertical, horizontal, or diagonal manner. In doing so, the user comes in contact with both their pieces and the pieces the other person has dropped, if not directly, through those tokens having to pass through the same game board that their pieces are. This creates a problem for spreading germs, especially during a pandemic. Furthermore, meetings between multiple people from different households are ill-advised during such a time. Towards this end, we developed a robotic Connect 4 game board so that the user could play against the algorithm and not touch any of the pieces. This makes the board useful in a public setting, as minimal disinfecting needs to be done. The only direct interface the user has with the game board is through a solid surface keypad that can be easily cleaned after usage. The game board, through the algorithm, drops the tokens both for the user and for the algorithm playing against the user through the use of the positioner. As the game is completed, the algorithm checks to see if anyone has won. If no one has won, gameplay continues. Once someone has won, the game declares a winner and prepares for sorting. The tokens are dropped through the columns by the crankshaft and the pins, tokens sorted, put in their respective columns, and the game reset for another user.
This is the positioner system. It's comprised of an 8mm T8 lead screw and its associated lead nut, an 8mm linear guide rod, a NEMA 11 stepper motor, 4 1/8" precision ground guide rods, a power spring, and the dropper itself. It operates simply by being driven along the lead screw, left or right here, to the proper column. Once there, the pieces are dropped along this guide system atop the power spring and fall through a slot in the positioner. After that, the system continues to play until the game is over, and then it goes into a storage position. I'll give you an example of this here in a second. Before the pieces are played, it registers off of a limit switch here so that it knows its exact position. Good. So the system is going to reset here and play. This is the release mechanism. It's comprised of 7 release pins, 7 springs that hold each release pin in its standard position, the crankshaft, 1 NEMA 11 stepper motor, and various structural components seen here. Currently we have 3 game pieces held in place as a demonstration. The crankshaft has 8 positions, 7 of which are physical and 1 of which is not. Each position on the crankshaft releases the pin, its associated pin, at a 45-degree interval. So when the first pin is released, 45-degree rotation from there will release the second pin, 45 again, and so on and so forth. The last 45-degree segment is a neutral position in which no pins are released. The zeroing of the crankshaft is done by a limit switch here. And let's go ahead and give this a run through to show you guys how it works. This is the sorting mechanism. It's comprised of a channel, the top to that channel, a NEMA 8 stepper motor, the stopper arm as well as the stopper, the paddle on the inside, and its structural components as well. It operates by having a single coin roll into the position here that my pointer is in. No other piece can roll into that position because the back side of that piece stops it, at which point the sorter either moves to the left or to the right, and sorts the single piece that's held in there. Subsequent pieces are stopped from rolling into that position by this mechanism here, the stopper. Once it resets back to its neutral position here, the next piece falls into the previous slot, and rinse and repeat. The zeroing for the NEMA 8 here is handled by a limit switch located underneath this NEMA 11. We currently have an orange and a purple piece on the game board. We will sort both of them here shortly. What was the noise?
My noise generator.
This is the elevator mechanism. It has 2 screws, 4 guide rods, a number of standoffs for the guide rods, and 3 sections of a large backing, as well as 2 lifts, 2 NEMA 17 stepper motors, and the base. This system works by pinning the game pieces in between this screw and the backstop. This screw has a 0.71 inch pitch, which is 0.01 inches larger than the diameter of each game piece, allowing for a 1/10 of a thousandth of an inch gap between each. These lifts lift the game piece from the bottom position to where the backstop starts. You can't see it here, but the backstop actually starts about here, after which the game pieces are locked in simply by the screw and the backstop itself. The backstop is sectioned into 3 different pieces. That's why you see these large brackets here. This was due to machine limitations, production limitations. This component here is a stabilizer for the screws. When loaded with all game pieces, when trying to drive the pieces up, the screw would deflect outward. So we put this in place to prevent that.
With a system as mechanically involved as this one, there were strengths and weaknesses. We'll cover that now. The translational element, in order to position the pieces, was a very strong point and a very good design. We had no problems with misalignment and tipping due to the use of a guide rod. And the tape served very well in allowing the pieces to move to all positions in the game board. The crankshaft was another very strong point. This served to retain the pieces when needed, and once the proper alignment using the stepper motor had been made, release the pieces without any hang-ups whatsoever. We did have some issues when the pieces were falling and hitting the bottom and bouncing, causing misalignment problems, which fed into sorter issues, and jamming coming through here. To alleviate this, we added small bits of neoprene, top and bottom, to prevent bouncing, which helped solve the problem, but did not totally eliminate it. The sorter was where we had most of our issues. Binding inside the sorter and at both ends, where different pieces were interfaced to the sorter channels, was a constant issue. We were able to solve some of these issues using the stepper motors and providing a bit of back and forth motion in order to wiggle things loose. The elevators served very well, especially once the anti-deflection device had been implemented. These solve the problem of token orientation by storing them in the same position in which they go through the game board and the sorter. This also, due to the custom thread pitch, allowed for very simple control in releasing and gaining pieces back in at the bottom, as one revolution from the stepper motor corresponds to 1 token.
So right now we're going to start a new game. We're going to hit the little 1 key to start a new game with me as the first player. And then I hit 1 to go in the first column. We got this little corkscrew to go up, and we'll drop 1 orange piece for the player. The AI will select the column to go. I'm going to do 1 again.
The The elevator on the back drops a purple piece for the algorithm's move.
Now that we've played a little bit, I'm going to go ahead and reset the game by hitting star. First things that will happen is these corkscrew elevators will drop so that one token is right above the entrance hole. So we don't have any gaps in these elevators.
The crankshaft on the back will pull a pin. The pin will release a column of tokens at a time. We release one column at a time to avoid binding issues with the travel down to the sorters. The sorter will then select a piece based on which one rolls in, and from the memory stored in the gameplay algorithm, the sorter will direct a token to the left or right corresponding to the color. Naturally, you want the orange tokens to go to the orange elevator, and you want the purple tokens to go to the purple elevator.
Now the game is reset. We can play again. Hit 2 to do the AI's move. So the AI goes first this time. Now I'll go 4. And that's a little game.